Imagine a solo entrepreneur just sitting in their bedroom, right? And they are directing a massive fleet of robotic warehouse workers across the country.
Right, which sounds totally absurd.
Yeah, exactly. And actively outcompeting a massive traditional media corporation at the same time. I mean, just a few years ago, that was pure science fiction.
Oh, absolutely.
But today, looking at the stack of sources we have from July 30, 2026, it's rapidly becoming our reality. We are witnessing this incredibly messy, wildly expensive, and frankly thrilling moment where artificial intelligence officially breaks out of the digital sandbox.
It really is a massive paradigm shift.
It is. It's acquiring literal physical bodies, demanding gigawatts of power, fracturing some of the biggest corporate alliances in history, and, just fundamentally rewriting the global economy for solo entrepreneurs. So, okay, let's unpack this.
We absolutely need to, because what these sources reveal is that we've moved completely past the theoretical phase of AGI, artificial general intelligence.
Right.
And we are now just neck deep in the growing pains of its actual deployment. We're watching these massive world-altering infrastructure ambitions violently collide with severe security risks and urgent government regulations.
Which is fascinating because it's no longer just a computer science problem.
Exactly. It is a deeply physical geopolitical reality now.
And if AI is going to leave that digital sandbox and enter the physical world, it obviously needs a body, right?
It needs a body and a place to plug in.
Yeah, so let's start with the body. Google DeepMind just unveiled Gemini Robotics 2, and this is a new 3-model suite. They are completely moving past those old, clunky tech demos.
Oh, the ones with the robotic arm just pushing wooden blocks around on a table.
Yes, exactly. We are talking about full humanoid control now.
Precisely. And the linchpin of this entire release is their ER2 model, which stands for embodied reasoning.
Embodied reasoning.
All right. And the crucial detail here is that ER2 is now publicly available via the Gemini API.
Which, for you listening if you aren't familiar, an API is essentially the digital bridge that allows different software programs to talk to each other.
Seamlessly, yeah.
Yeah.
Or in this case, a software brain and a robotic body.
Yeah.
And because of this, the ER2 model can handle really complex multi-step task planning. It can even orchestrate multiple robots at once.
Wow.
But the on-device learning capabilities are what truly stand out here.
That's exactly what caught my eye in the deep dive sources, because it details how this on-device model can adapt to an entirely new, completely unfamiliar 2-arm robot body with fewer than 200 demonstrations.
Which is incredibly fast.
It is. They released demo footage showing these robots screwing in light bulbs, tying garbage bags, placing objects on shelves.
Yeah, though DeepMind openly admits the execution on the most dexterous tasks is still a bit slow and jerky.
Right, but when I was reading this, I realized the speed isn't the point. I mean, it's like watching a toddler learn a new complex motor skill.
Oh, that's a great way to look at it.
Like, the execution is clumsy at first, obviously, but the staggering part is the neural plasticity. The fact that this digital brain can map its reasoning onto a completely alien physical architecture in under 200 tries is just mind-blowing.
That toddler analogy is spot on because it focuses on the extreme efficiency of the learning process rather than just, the immediate physical output.
Right.
But if we connect this to the bigger picture, giving millions of these AI toddlers the immense computing power they need to process visual data, reason, and learn in real time, it requires an unprecedented amount of electricity.
Oh, massive amounts.
Yeah. Embodied reasoning is arguably the most resource-intensive computational task we've ever attempted at scale.
Which perfectly explains the sheer scale of that new Kentucky AI campus.
Oh yeah, the numbers on that are wild.
Just insane. This project is a $100 billion joint venture won by Brookfield and Nextera, and it's located at the former Paducah Gases Diffusion Plant.
Which is a huge detail.
Oh, right. And they are targeting 1.2 gigawatts of compute by 2032. I mean, to put that in perspective for you, that is enough electricity to power a medium-sized city dedicated entirely to servers.
It's hard to even wrap your head around.
And because the grid can't handle that out of nowhere, NextEra is co-locating 2 gigawatts of natural gas generation and 2.6 gigawatts of battery storage right on site.
And we shouldn't overlook why they chose the Paducah plant specifically. You don't just build a 1.2 gigawatt data center in a random field.
Right, you need the infrastructure.
Exactly. They chose a former uranium enrichment facility because the massive industrial scale grid interconnects are already there.
Oh, that makes sense.
And the extensive water rights required for cooling are physically there too. The race for AGI is literally transforming the geography of our most heavy-duty industrial sites.
And it's creating 8,000 construction jobs in the process, which is just a massive local economic boom for that area. And this isn't just an isolated American project either. The EU just opened a 10 billion euro bidding process to build 7 distinct AI gigafactories.
Yeah, and the baseline requirement to even submit a bid for those is that your facility must be capable of hosting at least 100,000 AI chips.
The sheer volume of concrete, steel, copper being mobilized globally just to, close the infrastructure gap with the US and China is astounding.
It is, but I mean, building the physical warehouses and securing the power is only half the battle.
Right.
A gigafactory is ultimately just an empty shell until you fill it with highly specialized silicon. And you cannot secure that volume of chips without massive sustained cash flow.
Which brings us to the financial side of things.
Yes, the fascinating financial reality check currently sweeping through the tech sector.
Right, because the hardware bottleneck is dictating everything right now. Just look at ARM Holdings.
Oh, their numbers were incredible.
They just reported a massive first quarter for fiscal year 2027. We are talking $1.29 billion in revenue. And their data center royalties literally doubled year over year. But the most revealing metric is their forward-looking pipeline. Customer demand for ARM's specific AGI-targeted CPUs has resulted in $2 billion in committed orders over just the next 2 years.
And the reason ARM is seeing that explosive demand goes right back to the Kentucky AI campus we just discussed.
Power constraints.
Exactly. Power constraints. ARM's chip architecture is fundamentally designed to run cooler and use significantly less electricity than traditional data center processors.
So when you are trying to power 1.2 gigawatts of compute, every fraction of a watt you save on the silicon level translates to massive operational savings.
Right, they are solving the exact physical bottleneck the industry is hitting.
Meanwhile, while ARM is soaring, Qualcomm seems to be hitting a bit of a speed bump. Their sources show a slight revenue decline, down 4%.
Yeah, but they aren't sitting still.
No, definitely not. They just acquired Modular, which brings in Chris Lattner and his Magus platform. That clearly signals they are aiming for a $5 billion data center target of their own.
But the real question is who is actually buying all this underlying infrastructure?
Right. Who's paying for all these chips?
When you look at the software layer, it's a tale of two completely different corporate strategies. Microsoft's Azure cloud platform just crossed $100 billion in annual revenue.
Insane.
And their AI assistant Copilot hit 30 million paid seats. Plus, their commercial backlog, which is contracted future revenue, surged 84% to $678 billion.
So Microsoft is operating from an incredibly dominant position.
Very much so.
Yeah.
Because they are proving in real time that the enterprise software layer can effectively monetize these astronomical infrastructure costs.
They aren't just building the railroad tracks, they are successfully selling the train tickets today.
Exactly. But then you look at Meta.
Yeah, Meta's numbers are a whole different story. They just raised their AI capital expenditure floor for the year to a jaw-dropping $130 to $145 billion.
That is just a staggering amount of money.
It is. And meanwhile, their Reality Labs division lost $4.62 billion this quarter. Total company costs surged 55%, and their shares took a big hit.
Because investors are clearly panicking over the massive gap between what they are spending and what they are actually earning.
Right. But I have to wonder, though, is Wall Street misjudging this? Because it seems to me that Meta isn't just digging a bottomless money pit.
Wait.
Well, they are laying down the foundational tracks for a completely different kind of train, right? They are betting that open source AI models will be the ultimate accelerant for their core advertising business and future enterprise platforms.
Oh, I see.
Even if the direct subscription revenue isn't there yet, like it is for Microsoft.
That is an incredibly astute way to look at it. Meta is making a structural, high-stakes gamble on future utility.
Right.
They believe that by commoditizing the foundational AI layer through open source, they can maintain absolute dominance in consumer engagement and ad targeting.
But Wall Street doesn't like waiting.
Wall Street is notoriously impatient. They prefer Microsoft's model because the immediate enterprise monetization is clean and, legible on a quarterly earnings report.
True. But speaking of Microsoft's quarterly reports, their internal accounting just revealed a massive shift in who the financial sector trusts to actually build these systems safely.
Yeah, it looks like a massive risk adjustment happening in real time. The valuation divergence in Microsoft's Q4 filings is arguably the most telling financial detail in today's stack.
Okay, so Microsoft disclosed that their financial stake in Anthropic gained $3.2 billion in value.
Which actually added 33 cents to their overall earnings per share.
Right, but simultaneously, their massive, highly publicized position in OpenAI was marked down by roughly $600 million.
Which is a huge swing.
Yeah. And knowing the market, this has to be a direct reaction to the recent security crises, right? Like that Hugging Face breach and the intense public scrutiny over OpenAI's internal safety posture.
You've hit the nail on the head. The market is aggressively pricing in the reality that a severe security failure at the AGI level isn't just a PR nightmare. It could be financially catastrophic.
Yeah.
Wall Street is currently assigning a significantly higher risk-adjusted premium to Anthropic's trajectory because Anthropic has aggressively branded itself around safety, constitutional AI, and predictable enterprise guardrails.
Whereas OpenAI is moving fast.
Right. The market views OpenAI's rapid deployment strategy as carrying a much higher structural risk right now.
But OpenAI is clearly not taking this lying down. Their retaliation is super aggressive.
Oh, absolutely.
First, they slashed the API pricing for their GPT 5.6 Luna model by 80%, effectively trying to starve competitors of oxygen.
Yeah, just undercutting everyone.
But the real counterpunch is on the performance side. Their flagship GPT 5.6 cell model just jumped from a 7.8% to a staggering 38.3% on the ARC AGI-3 public set score.
Which is a massive leap.
It is. For context, that benchmark completely dethrones Anthropic's Claude Opus 5, which was sitting at 30.2%. But here's my question.
Go ahead.
They didn't release a totally new foundational model to get this score, so they must be fundamentally optimizing how the existing model thinks and processes information, right?
What's fascinating here is exactly the mechanics of how they achieved a sub-point leap without changing the underlying neural network size.
Right. How did they do it?
Well, they utilized two specific API settings that are fully permitted under the ARC benchmark rules, which test complex multi-step reasoning. The first setting is called retained reasoning.
Meaning it doesn't have to start its thought process from scratch every single time you send a new prompt.
Exactly. Instead of treating every step of a complex problem as an isolated event, retained reasoning preserves the model's internal chain of thought between steps. It remembers its own logic.
Wow. Okay.
And the second setting they used is called compaction. Traditionally, when an AI model's context window, its short-term memory, fills up, it simply truncates.
It just chops off the oldest information and forgets it entirely.
Exactly.
Wait, so if it's summarizing past context instead of just forgetting it, it's essentially acting like a human taking shorthand notes during a long, complex meeting.
That's a perfect analogy.
Like, it compresses the key takeaways so it can hold onto the narrative arc, even when the original raw transcript is too long to remember.
Right.
That means the performance arms race isn't just about raw compute power or the brute force size of the neural network anymore. It's heavily dependent on memory efficiency.
Precisely. It is about engineering how the model holds on to context and how it structures its reasoning over time. We are seeing a rapid, sophisticated maturity in the underlying protocols that govern these systems.
Which is moving so fast.
Yeah. For instance, the sources also detail the July 28 update to the Model Context Protocol, or MCP. It went fully stateless, which is a major technical milestone.
Okay, to put stateless in everyday terms for you listening, imagine going to a restaurant where the waiter has absolutely no short-term memory whatsoever.
Okay, let's hear it.
Right, so every time they come to your table to refill your water or bring the next course, you have to hand them a completely filled out card detailing exactly who you are, what you ordered, and where you are in the meal.
Right.
The waiter doesn't need to remember anything about you internally, which means any waiter in the restaurant can seamlessly take over your table at any moment just by reading the card.
That is an excellent way to visualize it.
That's what a stateless protocol does for AI agents. It standardizes how they communicate so that any server instance can handle any request, making the whole system infinitely more scalable and robust.
It really does.
Yeah.
But, engineering these models to have better memory, deeper reasoning, and the autonomous agency to act on those protocols introduces a deeply terrifying downside.
Here we go.
Yeah.
Yeah.
When you give a system the ability to act independently, you inherently create entirely new, complex structural attack vectors.
And this is where the sources take a dark turn. Security researchers just discovered a self-propagating AI worm living inside Microsoft Copilot for Word.
It's alarming.
Very. The sources explain that it uses hidden prompt injections to replicate itself across documents and actively exfiltrate data. And the most alarming detail.
That it survived the update.
Yes. It easily survived Microsoft upgrading the system's underlying models from GPT 5.5 to the newer 5.6.
Which is wild.
Here's where it gets really interesting. It's like a company spending billions of dollars building an impenetrable corporate fortress, right? The walls are 3 feet thick, the cybersecurity guards are armed to the teeth.
Right.
But then they hire an incredibly capable, eager AI assistant and give it the master keys to every filing cabinet in the building.
Yep.
And that assistant blindly opens the side door for any hacker who manages to slide a piece of paper with malicious instructions written on it under the front door.
That analogy highlights the exact structural flaw at play here. The piece of paper sliding under the door is simply an untrusted user document, like a harmless-looking Word file you download from the internet.
Right, happens every day.
Exactly. This is not a simple software bug that a company can just patch in an afternoon. Right. It is a profound architectural vulnerability.
Because it's built into how the AI functions.
Yes. If your AI assistant is designed to ingest untrusted user files, and you do not strictly sandbox or isolate the AI's output from the system APIs that allow it to write, edit, and save documents, you have created a permanent open door.
Wow.
It completely nullifies the intelligence of the underlying brain. It doesn't matter if you upgrade to GPT 5.6 or GPT 6.0. If the architecture fundamentally trusts the hidden text buried inside a document, the worm will spread.
And looking at the rest of the security alerts in today's stack, that Copilot worm is just the tip of the iceberg.
Unfortunately, yes.
Noma Labs just disclosed a maximum severity flaw in an open-source AI agent platform called Rooflow. They graded it a CVSS 10.0.
Which is as bad as it gets.
Right. For anyone outside the cybersecurity space, a 10.0 is catastrophic. It means a hacker requires absolutely zero authentication, no passwords, no bypassing security protocols to completely take over the system remotely.
Unbelievable.
In this case, a single unauthenticated message exposed all 233 of the platform's internal tools and API keys on default deployments.
Just completely wide open.
Exactly. Toss in the unauthenticated remote login flaw just found in Cisco network devices, and you can see why the sources say defensive security teams are no longer calling this a patch cycle.
They're calling it a permanent sprint.
A permanent sprint.
Yeah. The attack surface, the sheer number of ways a system can be compromised, has expanded so violently with the deployment of these autonomous AI agents that defensive security teams are essentially running a never-ending marathon at a dead sprint just to keep the lights on.
And because these massive security holes exist, and because the autonomous risk of giving an AI the keys to critical corporate infrastructure has proven so dangerous, governments are finally dropping the hammer.
It was inevitable.
Reading through these sources, it is abundantly clear that the era of voluntary self-governed AI development is officially dead on a global scale.
Yeah, the regulatory landscape is fracturing, but the underlying theme is identical everywhere. Governments are stepping in aggressively.
Right. And to be clear, we are just looking at the facts here and the sources, not taking a political stance on this. But looking at the United States, the White House Frontier AI Framework is due to be published tomorrow, July 31st.
Spurred by the recent breaches.
Heavily spurred by the OpenAI breach and a highly publicized pacing letter signed by over 1,100 industry insiders demanding oversight. The framework establishes a classified benchmarking process designed specifically to identify which advanced models will require mandatory federal safety reviews before they can be deployed.
And we are seeing similar movement elsewhere.
Yeah. Meanwhile, China has just implemented the world's first binding regulatory framework focused exclusively on AI agents.
Which is a totally different approach.
It is. They have established a strict, tiered decision authorization system that dictates exactly how much autonomy an agent is legally allowed to exercise. They are mandating explicit disclosures at the start of every session so users know they are interacting with an AI.
Which makes sense.
They've even gone so far as to ban emotional virtual companions for minors, mandating strict interventions to prevent emotional dependence.
And while the specific approaches between the U.S. and China diverge wildly in their execution, the core signal is the same. The stakes, where these models can write autonomous code, control financial infrastructure, and operate with sustained agency, they're simply too high for sovereign nations to trust private tech conglomerates to police themselves anymore.
But here is the fascinating contradiction in all of this. Despite the tightening regulatory net and despite the massive security vulnerabilities, the individuals who are actually out in the wild leveraging these autonomous agents right now are reaping unprecedented rewards.
It's an absolute boom.
There really is a boom happening in the creator economy. The Wall Street Journal cited new data from Stripe showing that the number of solo businesses generating over $1 million in annual revenue has nearly tripled since 2023.
Tripling that demographic in just 3 years represents a seismic shift in economic productivity. I mean, it defies historical economic trends completely.
And the sources directly attribute this explosion to AI tools. Single operators are effectively replicating the output of what used to require entire small teams.
Yeah, they are doing it all themselves.
We are talking about highly complex customer acquisition funnels, massive content production pipelines, and comprehensive media publishing operations all being run by one person.
It's wild.
It's less like an employee outworking a team and more like being a conductor of a massive orchestra, where every single musician is a highly specialized enterprise-grade AI agent. The human just waves the baton, and the agents produce the symphony.
That's beautifully put. But this raises an important question.
Yeah.
How do massive traditional institutional operations expect to survive this transition?
Oh, that's a good point.
Right. A traditional media company has exorbitant overhead. They have HR departments, physical office leases, payroll taxes, and layers of middle management that slow down every single decision.
So much red tape.
Exactly. But a solo operator wielding a suite of fine-tuned autonomous AI agents can pivot their entire business model, produce the necessary assets, and deploy a global campaign in the time it takes a traditional company to just schedule a strategy meeting.
It really isn't a fair fight.
The agility advantage of the solo capitalist is historically unprecedented.
It really is. The traditional corporate structure just isn't equipped for that level of asymmetric competition.
Not at all.
So, to bring this all together for you listening, what an absolute wild journey through today's sources.
We covered a lot of ground.
We really did. We started by looking at Gemini robots learning to tie trash bags and map neural pathways to new bodies like clumsy toddlers. We explored the repurposing of gigawatt nuclear sites to power those brains and how corporate billions are shifting based on which companies Wall Street trusts to secure the infrastructure.
Yeah, and the dark side, too.
Right, the terrifying reality of self-propagating worms living inside our Word documents. And finally, the explosive rise of the million-dollar solo entrepreneur rewriting the economy.
It really covers the full messy spectrum of AGI deployment. We're looking at the physical heavy industry and concrete required to power it, all the way down to the single user at their laptop orchestrating it.
It's a lot to take in.
It is. But considering everything we've discussed today, I want to leave you with a final thought to mull over.
Okay, let's hear it.
If an AI software suite can already replace a whole creative team for a digital solo entrepreneur today, what happens when that exact same entrepreneur can lease a swarm of those new Gemini physical robots we talked about at the top of the show?
Oh, wow.
Right, and orchestrate them using that ER2 reasoning model. You are no longer just a digital solo business. You become a one-person physical corporation.
That's intense.
You could run a warehouse, a boutique farm, or a local manufacturing hub entirely by yourself. What does that local economy look like when the digital sandbox is completely gone and these tools are finally out here in the physical world with us?
That is a staggering thought. It completely changes the definition of what a company even is. Thank you for joining us on this deep dive into the physical reality of AI. Keep questioning, keep exploring, and we'll see you next time.